Today's lesson, how to graph sine and cosine. So I'm going to kind of give you the bare bones lesson today in this video. If you want a little bit more detail on exactly where this comes from, then check out my second video. I'll put a second video here on Canvas that will go into a little bit more detail into like why this happens. But the video we're on right now, I'm just going to stick to the bare bones, exactly what to do. When you go to graph y equals the sine of x, you always are going to start at the origin. And that's probably the most important thing to remember with sine. Start at the origin. This is kind of like the parent function of sine here. And then sine completes one full cycle every 360 degrees. So in 360 degrees, you're also going to end on the x-axis. Okay? Another thing is halfway between, at 180 degrees, the sine curve is going to pass through the x-axis. And then if you split these kind of into quarters, if you take the halfway point between 0 and 180, this is when sine reaches its maximum peak. And then halfway between 180 and 360, this is when sine reaches its lowest point. So the graph of y equals the sine of x, kind of the parent function, it's going to be a curve that starts at the origin. It travels up to its peak in 90 degrees, travels back down to the x-axis at 180, travels to its lowest point. Sometimes I call this its valley at 270 degrees. And then back to where it started at 360 degrees. Now this is one sine wave right here. Now the reality is this pattern would continue where in 90 degrees it would hit another peak. 90 degrees later it would come back to the x-axis. 90 degrees after that it would reach its lowest point. And 90 degrees after that it would come back to its original starting place. A lot of times when I draw these graphs, a lot of times I'll just draw the first cycle. But realize the reality is that this would continue going on and on. You could actually put an arrow at the end of it to show that this goes on forever. Now, what's different about cosine then? So the graph of cosine then, cosine always starts at its extreme highest point. So the parent function of cosine is actually going to start up here at 1, and that's as high as it goes. And then basically every 90 degrees it reaches a new kind of new milestone. So in 90 degrees it's going to be back to the x-axis. At 180 degrees it reaches its lowest point. 270 degrees back to the x-axis. And then at 360 degrees back to where it started at its highest point. Now this is not a straight line. Okay, I drew all these little dots here. This does not make a straight line by any stretch. At all times, it is curving. So imagine kind of trying to draw like an S curve through these lines. It curves down to the x-axis, curves to its extreme, and then likewise, it's almost like drawing S curves between these points. This is one cosine wave. Now this would continue, every 90 degrees, kind of hitting a new benchmark. So here's what it would look like if we continued to graph that. You could even put an arrow at the end to show that this graph goes on and on forever. Now, what I would write down, so I'm not going to lie, this lesson's really going to be hard for me to do on YouTube, much easier to do in person, but my advice to you, here's what I would write down for one sine wave, like to kind of have in your notes. And this is something I'll be putting on my board. For the sine wave, one sine wave, you really want to kind of clarify these key points, okay? And realize that the sine wave starts and ends on the x-axis. Okay, so I would hit pause right now and just copy this down on a scrap sheet of paper in your notes. This is one traditional sine wave, the parent function. And then likewise, I'm going to switch this down to the cosine wave. I would pause here, copy this down in your notes. One cosine wave, cosine starts and ends at its extreme high. So cosine starts up high, it goes through one cycle, and it ends up high as well. Okay, so the graphs that I just showed you, these are called the parent functions of sine and cosine. But just as we learned when we studied transformations, the transformations of graphs, you can transform a sine wave or a cosine wave and make it have, a steeper slope or a different location. So we're going to focus on two types of transformations you can do to a sine wave. The first is called its amplitude. Okay, so with a sine wave, if you ever have a number being multiplied in front of the word sine or even in front of the word cosine, this is called its amplitude. Here we would say that A, in this example, we would say that A is equal to 3. And what this is going to do, so my sine, being sine, this is still going to start at the origin. So sine starts at 0, 0, right? But then, when it goes up in 90 degrees, when it goes up to its maximum point, instead of just going to 1 here, because of this new amplitude, its maximum point now is actually going to go all the way up to 3. Okay? And then 90 degrees later, it's going to go back to the x-axis. Now 90 degrees after that, it's going to go to its lowest point. Now, since the amplitude is 3, our lowest point now is going to be -3. Okay, and then 360 degrees back to where it started. So this is still the same sine wave, it just goes a lot taller. And now, instead of going to a height of just 1, now its maximum height is going to go all the way up to 3. And then it's going to bottom out down here in its valley at -3. So technically, the technical definition of amplitude is the distance from a sine wave's line of equilibrium, which is traditionally the x-axis. It's the distance from this line of equilibrium to its maximum height. So there's a distance of 3 from here to here, and also from its minimum height. There's also a distance from here to here of 3 as well. So that's called the amplitude. Okay. Now again, this would continue. I traditionally am in the habit of just drawing one of the very first cycle of the sine wave. But yeah, absolutely realize that this would continue on and on and on. Okay, now you can also, as in this case, have a smaller amplitude. You can shrink the amplitude of a graph. Here we would say A is equal to 1/2. Now cosine always starts at its extreme high. So here, the highest this graph is going to go, it's only going to go up to 1/2. Okay, 90 degrees later, it would come back to its to the x-axis. Now 90 degrees later, here, this graph is going to reach its extreme low, which because the amplitude is only 1/2, the lowest this graph is going to go is -1/2. 270 degrees back to the x-axis, and then at 360 degrees back to its extreme high. Remember, cosine begins and ends at its extreme highest point, but in this case, that highest point is only 1/2. So here is the first cosine cycle, and of course this would continue. It would continue just as well, but whoops, I might have even screwed that up a little bit. Sorry, whoops, yeah, I did. Here's why. This is why. Oh boy, I kind of made a mess of that. But hey, the first cycle is correct. That's what you want to focus on, and then that pattern would just repeat. Okay, so those were examples that dealt with what's called the amplitude of a sine wave or a cosine wave. Now we want to focus our energy, and amplitude is designated by this letter A. Now we want to focus our energy on this B. Imagine there's a multiplier inside the parentheses right next to the x, like we have right here. Here we have a 3. Here we could say B is equal to 3. What is that going to change in the graph? Well, what this is going to change what's called the period of the graph. So traditionally, the period of a graph is 360 degrees. A sine wave completes a cycle every 360 degrees. However, if this value B changes, if it's a number other than 1, that's actually going to shrink or enlarge the period. So here we have a period of 360. The formula says that the period of a sine wave is 360 degrees divided by B. Well, if B is 3, that's going to divide our period by 3. That's going to give us a new period of just 120 degrees. Now, what does that mean about our graph? Now, remember, sine, of course, starts at the origin. So this means that my entire sine wave now, the entire cycle now, all has to be accomplished in only 120 degrees. So looking back at like my original parent function of a sine wave, what's going to happen now is now, originally a sine wave has a period of 360 degrees, and all of this happens. But now imagine shrinking this entire sine wave now. Instead of being 360 degrees, now it's all has to happen in only 120 degrees. Okay, so here's what this is going to look like. Now this sine wave, now it still has an amplitude of 1. You can imagine there being an invisible 1 here. So you can still just say that the amplitude is 1. But now my sine wave is going to go all the way up to 1 in just like a third of the space. It's going to go all the way up to 1 and back to the and back to your x-axis, and only that all happened in just 60 degrees. And then it's going to go all the way down to -1 and back to the x-axis. Listen, that all happened in just 120 degrees. So see how compressed that got? This is what happens when you start giving a b-value. A large b-value really compresses your graph. So here, a b-value of 3. This entire sine wave now, all of it just happened in only, zoom in so you can see that that's truly 120 degrees. Okay, it hit its halfway point here at 60 degrees, and then the whole thing happened in just 120 degrees. All right, so let's look at a cosine now. Okay, and this is going to be even crazier. Here we have a b-value of 4. So remember, the formula is the period is 360 divided by 4. So here, the period is only going to be 90 degrees. That's a very small period. So now my entire cosine wave, and let me try to zoom in on this a little bit. My entire cosine wave now is going to have to all happen within this 90 degrees here. Now cosine, remember, starts at its extreme high, and you can imagine an invisible 1 here. Okay, so the amplitude is just going to be 1. So the cosine is going to start at its extreme high of 1. It's going to travel all the way to its extreme low by 45, and then back to its extreme high, all within just 90 degrees. It's kind of insane, but the entire cosine wave, all of this cosine wave that you see from the parent function, this all now has to happen in only 90 degrees. So, I'm going to draw it. Here it is hitting its extreme low at only 45 degrees, the halfway point. And then back up. There, all of that, that entire cosine cycle happened in only 90 degrees. All right, so let's start doing some questions right off of your assignment, because I think this is going to be a tough assignment. Okay, so let's just look right off the bat. Question 1. Find the amplitude and period in degrees of each function. Y equals 2 times the sine of theta. All right, so the 2 here, the 2 in front of the word sine, this indicates the amplitude. So simply put, we're going to say that this first question, the amplitude is 2. Okay, so this first column is meant to be amplitude. In the second column, you have to list the period in degrees. Okay, now let's look at the period. So you'll notice that this question does not have a b value. If you really wanted to, you could put like a 1 in front of the theta. Okay, you could technically say there's nothing there, but you could technically say that this has a b value equal to 1. So remember the formula for period. Period is simply 360 degrees divided by b. So here we're going to go 360 divided by 1. It is 360. In other words, if there's nothing here, if there's no b value, you can say that b is equal to 1, and the period would be 360 degrees. Okay. Now let's scroll down. Let's scroll down to one that does have a b value, just to remind us here. So in this case, there is no amplitude listed, but you could put an imaginary 1 there. Here you could say that the a is equal to 1. Okay, there's kind of an invisible 1 that you can't see, but you can place a 1 there. But then here, since b is equal to 3, we would do 360 divided by 3 is 120 degrees. Okay, now realize that you can have both things happen here. Okay, here, and let's actually look at this example because this is a great example. This has something kind of interesting happening. So the amplitude is always super easy. The amplitude is just this number in front of the word sine. Our amplitude is going to be 1/2. Okay, a is equal to 1/2. Now here we have a very unique case where b, here the x is actually being divided by 2. Now if this ever happens, if you ever have like x being, or theta, x and theta are interchangeable. Don't let that mess you up. But if you ever have your variable, your angle being divided by 2, here you actually have to say that b is equal to 1/2. Okay? And like down here, you'd have to say b is equal to 1/4 because it's being divided by 4. And if b is ever a fraction, if you ever have your angle being divided by a number, here's what it looks like. When you try to take 360 divided by 1/2, and if you don't believe me, try it in your calculator. What happens? It actually doubles the number. 360 divided by 1/2, as long as your 1/2 is like in parentheses. Listen, it comes out. It doubles the number. It makes it 720. Down here, this b value of 1/4, that's actually going to quadruple the number. We take 360. When you divide by 1/4, that's the same thing as timesing by 4. Okay, that's going to come out to 1440 degrees. It's going to be a very large period. Okay, so I tried to give you help on this. I know this is going to be kind of a tough lesson, but hopefully that's a good help to get you started on that. And let's also look at question 6, because here we're kind of going backwards. Here, in question 6, here they're actually showing you the graph, and you, from that, have to determine which of these is the correct function. Okay, so right off the bat, this graph starts here at the origin, so I know it's going to be sine, okay, which all of my choices have sine anyway, but right off the bat, that's a good place to start. And then let's look at the amplitude. So the highest that this graph ever goes is at 1. Okay, you can see it doesn't quite make it to the 2. The lowest it ever goes is -1. We're going to say the amplitude is 1. Okay, now again, this doesn't really help us because you can imagine all of these having like an invisible 1 in front of them. So all of these choices have an amplitude of 1. What this is going to come down to is the period. Now, if you look at this graph starts at the origin, and it does one complete cycle in only 90 degrees. So here we would say that the period, by looking at the graph, is only 90 degrees. So we need to find the b value that matches this period. Well, another really, so we already learned that the period, this is a formula we learned earlier that if you don't have in your notes, make sure you write this down. We already learned that the period is equal to 360 degrees divided by b. But I want you to realize you can actually flip-flop the period and the b. You're actually also allowed to say that b is equal to 360 degrees divided by the period. So if you ever know what your period is, but you're trying to find the b value, just use this formula. B is going to be 360 degrees divided by 90 degrees. It just comes out to 4. Okay, so the only choice here that has a b value of 4 is D. The correct answer is D. All right, and then why not? Let's just do question 11 to kind of wrap this up. So here I have to select the graph that matches this function. This has an amplitude of 3. It has a b value of 2. Now, if the b value is 2, that means our period would be 360 divided by 2. Our period would be 180 degrees. So the correct answer is B. Not only because it has the correct amplitude, which the amplitude is often just a great giveaway. Notice the amplitude here. This is actually the only graph that has an amplitude that goes up to 3 and down to -3. So right off the bat, you know it has to be B just by looking at that. But also look at the period. The period of 180, this graph does a complete cycle. It goes all the way up, all the way down, back to where it started. in just 180 degrees. So without question, the answer is B. All right, hey, this is going to be a tricky assignment, and I know this was a really long video, but I wish you the best. Take care. Bye.